Okay, so today we are going to discuss sound waves. As you already know, in our previous discussions, we spoke about waves in general, and then in it we described mechanical waves and then longitudinal waves. As a matter of fact, sound waves falls under mechanical wave, and they are also longitudinal in nature. So, having described that in our previous discussion, you will understand that sound wave being mechanical wave would require a material medium for their propagation. Okay, so without any material medium, then sound wave cannot be propagated. Also, they are longitudinal in nature, which means that their direction of travel is perpendicular to their propagation. All right, let me take that again. So they are longitudinal because their direction of travel is perpendicular to their propagation, which is at 90 degrees. I've touched on the fact that it's a mechanical wave and therefore requires a material medium for its propagation, meaning that sound wave cannot travel through vacuum. All right, they cannot travel through vacuum, and they can be compressed and then expanded. So under compression, high pressure, you have a series of compression and then rarefaction. That is where there is low pressure. Okay. All right. So this falls, all these discussions falls under the nature of sound waves. Okay. So we continue our discussion with the properties of sound waves. All right. Just like we touched on in the previous lecture, which is the general wave theory. If you've not seen that, I entreat you to go and then have a look at it to give you a bit of clarity on what we are discussing today. So we defined frequency as the number of oscillations performed by a particle per second, all right, and it is measured in hertz. Sound wave also being a wave has got frequency, and it is, as a matter of fact, um, a considering factor if you want to look at the pitch of a sound. Now, amplitude is the maximum displacement of a particle from its mean or resting position, like we said. So, greater amplitude will give you louder sound. All right. In our Ghanaian parlance, if you want to tell someone to speak out, you say amplify your voice. Now, all waves do have wavelength. That is the length between two successive crests or troughs, as discussed in our previous uh, engagement. And then there is the speed of the wave. The speed of the wave is the speed at which the wave travels through a medium. So, sound wave being a mechanical wave that will require a material medium for its propagation, it will travel through the various media via with certain speed, for lack of better words. To calculate the speed of a wave, or in this situation sound wave, we still use our equation v equals f lambda, and I think we took an example in our previous discussion, right? So wave being sound wave being a mechanical wave will always, its speed will always depend on the medium, right? So sound will travel fastest in solids because of the particulate of solid. They are closely packed and their particles are vibrating about a fixed point. Then same with liquids, because there is a bit of space in between the particles as compared to gas. It will be the slowest because the particles of gaseous substances are wider apart. All right. And then it is also influenced by temperature as well. So, when particles gain heat energy, they are able to convert it into kinetic energy. And kinetic energy has to do with movement. So, the more heat energy they are able to change into kinetic energy, the more kinetic energy they have to move about. And this will cause the wave to travel faster because it is being propagated through a material medium. All right. How do we hear sound? Okay. So there's the outer ear, which is the pinna, what we call willy. So it directs sound wave into our ears. Then the eardrum and ossicles, these are the tiny bones in the body. They are the tiniest in the body. They are found in the ear. There are three. They are known as the incus, the malleus, and then the stapes. They will take the wave coming in, the sound wave coming in from the outer ear, and then amplify it. It gets to the inner ear, which has the cochlea, all right, converts the vibration into signals for the brain to interpret. Now let's look at characteristics of sound waves. So for sound wave, it has something known as it has a characteristic feature known as a pitch. So it is the perception of the sound that we hear, whether the note is high or low. And then there is loudness. Loudness has to do with amplitude. It is measured in decibel. All right. Then the timbre or the tone quality is a distinguishing feature of sound that allows us to differentiate, let's say, the same note played on different instruments. So when I play, let's say, a note like C on a piano, and then someone plays a C on a guitar, you are able to say that, oh, this is coming from a guitar rather than a piano. Okay, so if I say do on piano is different from a do on, let's say, a bass guitar. All right, so this characteristic of sound is known as the quality or the timbre. All right, so now we get to talk about the behavior of sound waves. And with this, we are looking at reflection. Okay, reflection. Reflection is the bouncing back of wave. It's not only peculiar to light. So all waveforms are able to bounce back, which means they are able to undergo reflection. But for sound, um, the reflection is otherwise known as echo. So echo is a distinct reflected sound that is heard after a delay. Okay. So another twist is reverberation. So the persistence of sound in a space due to multiple reflection. So if there are multiple reflection, the scenario you experience is what is known as reverberation. Then refraction. Refraction basically has to do with the change in speed and direction of a wave. So with sound wave, it is the bending of the sound wave as they pass from one medium to another. Usually, um, like I said, the speed will change and then the direction may also change depending on the medium. So when they move from one medium that is denser than the other, so that the two media should be of different densities, okay, for the wave to experience refraction. Diffraction is the bending of wave as it moves through narrow aperture. So I want to annotate now. So for um, diffraction, okay, say I have a sound wave. I have a sound wave. Sorry, my XP pen is acting up. So for diffraction, okay, so it is the ability of the sound wave to move through narrow aperture ball. So if this is the sound wave, Okay, so the ability of the sound wave to meander through this whole narrow aperture is what is considered as what? Diffraction. Then with reflection, we are looking at a scenario where the sound hits a barrier, okay, then it comes back as such. So it travels this way and then that way. So the distance of the wave, because of echo, it has to travel and then go back to the observer or viewer. The distance is always times two. All right, take that into consideration. So back to the characteristics. All right, so here you see that it says diffraction is a bending of sound waves around an obstacle. So when you have an obstacle and the wave is able to meander its way through these obstacles, then it is living up to its characteristic, which is diffraction. Okay, so it goes on to say this explains why we can hear sound from around corners. When we combine two or more waves, where we have superpositioning of waves, it brings about interference. Then finally, when you have when you have two sound waves, okay, of nearly similar frequencies that are released together, okay, this is known as a beat. So I will explain beat again with an example. So this is an example on beats. And we know that to find our beat frequency, which is FB, it is equal to F2, which is the frequency of the first sound, minus, sorry, the frequency of the second sound minus the frequency of the first sound. We define beat as uh, beat is produced when you have similar frequencies, okay, sound of nearly similar frequencies that move together or they come together. So in our question, we say we have two notes of frequencies 415 hertz and 418 hertz are sounded together. Calculate the beat frequency. So our FB is going to be 4, it should be 418, not 481. 418 hertz. So because the frequencies should be similar, there shouldn't be a greater deal of difference between them. So 418 minus 415, and our beat frequency, which is FB, is equal to 3 hertz. So this is quite straightforward and very simple. Then in explaining the characteristics, we also touched on uh, echo, which is the reflection of sound. Okay, so if we have a sound barrier up here, we have an individual here that produces sound. So the sound travels in this direction, encounters the obstacle. Okay. Oh, I've gone way beyond. Okay. So this is a barrier. And then comes back this way. This is for the sake of demonstration. I want to show that the sound travels two times. So if this is x and this is x for the distance, we have x as one distance and then x as another distance. So we are going to have 2x. We know from motion that velocity is equal to displacement or distance over the time it took for the displacement to take place. I hope you people recollect that. So using a acquired notation here, we can say that V equals x over t in general terms. All right. But when it comes to echo, because the wave travels twice, so in and out, then x becomes 2x. I hope that is quite clear. So let's look at our question at hand and see if you are able to solve the question. Right. So let's put our solution here. So I read the question out. A boy stands in an empty room and shouts. So the boy is 5 meters away from the wall. So since it's an empty room, obviously there's going to be an okay. So this distance is 5 meters. Let me write my meters correctly. So from the wall. And it will obviously come back again in another 5 meters. So the sound is heard as echo. So therefore, uh, using our equation, we know our velocity is equal to 330 meters per second. Our time is what we are asked to look for. Our x is 5, but then since we have two of it, so times 2, right? So let's rewrite the equation here again nicely. 2x all over t. So we are looking for t. So let's put our 330 here. 2 times 5 all over the t we are looking for. Finishing it up, we have 330 equals 10 all over t. Okay, so we can multiply here by t, multiply here by t. I know you people don't like math, so I take my time to go through it in the kindergarten way. So we have 330 t here. If I say you people, I'm referring to my students. I know they don't like math. So we divide here by 330. We divide here by 330 as well. And therefore, our t is equal to 0.03 seconds. So I'll leave you to finish up with the second question. All right.